Hello everyone, welcome to this short video on hypothesis testing. In this video, we are going to perform the hypothesis test for the difference between two means using z-test. Couple of things we need to know before we begin with an example. The first thing is, as we are talking about two means, both samples must be the random samples. That is the first condition. Second thing, the sample must be independent of each other. So the sample taken will be 2 in this case, and between these two different samples, these two samples must be independent. That is, there can be no relationship between the subject in each sample. Third, the standard deviation of both populations, population from which the first sample is taken and the population from which the second sample is taken, okay, they must have the sample size, okay. If their sample sizes are less than 30, then in that case, those populations must be approximately normal or normally distributed. Meaning of that is, you have two different samples taken from two different populations. And if the sample sizes are less than 30, the populations, both populations, must be normally distributed or at least approximately normally distributed. In that case, when we perform the hypothesis test, the z value or the test statistic that we are calculating will be given by the formula which is here, z equal to the difference of two means, x1 bar minus x2 bar minus the difference of the population, that is mu sub 1 minus mu sub 2, all divided by the square root of population standard deviation of first squared over the sample size for the first sample plus the population standard deviation for the second squared divided by the second sample size. So that is the fundamental thing we need to know before we take an example and solve it. Let's begin with the example. Okay, here is the example. A professor at university wants to see whether there is a significant difference in ages of resident students and commuting students. He selects a random sample of 50 students from each group. The average age of a resident student, that is mean x1, equal to 22.12 years, and the average age of commuter student, that is x bar sub 2, is 22.56 years. At alpha equal to 0.05 or 5% significance level, we have to decide if there is enough evidence to reject the claim of no difference. So here the claim is there is no difference in the age of the resident student and the commuting students. Okay, so we have to decide if there is enough evidence to reject the claim of no difference in age of two groups. And they have given the population standard deviation sigma sub 1 for the resident student is 3.68 and sigma sub 2 for the commuting student is 4.7. So we are looking at the claim, and the claim is we want to see whether or not this is true. That is the claim. Okay, so that is the claim. So that should be H1 or alternative hypothesis because it has not equal to sign. So obviously your null hypothesis will be mu sub 1 is equal to mu sub 2. Okay, this is what we know. Now let's see what information is given about the resident student, okay, and the commuting student. Let's find out. They have given few pieces of information. Sample size is same for both, so n1 is 50, n2 is 50. Second is the mean for the first group of students is 22.12 Mean for the second group of students is 22.56. And the third thing, the standard deviation for first group of student is 3.68, and the standard deviation for second group of student is 4.7. Okay, since we know the population standard deviation, our test statistic will be the z-value given by the formula z equal to the difference in the sample mean minus the difference in the population mean, all divided by the square root of standard deviation of first population divided by first sample size, standard deviation of the second group squared divided by the second sample size. Let's substitute these values. So x1 bar is 22.12 minus x2 bar is 22.56 minus mu1 minus mu2. If mu1 and mu2 are equal, that must be 0, all divided by the square root of sigma 1 3.68 squared divided by n1 population. No, the sample size for the first one is 50. Also the sample size for the second one is 50. Second standard deviation is 4.7. 4.7 is squared. All this is inside the square root. If you calculate this using your calculator, your result must be negative 0.5212. Make sure you use your calculator and check this. Okay, once we have the z value, we are going to compute the p value because we are going to test this hypothesis using p-value method. Now, since we have not equal to sign in the alternative hypothesis, we know that this is a two-tail test. So p-value is the areas, the sum of areas on the two tails of the normal distribution. Okay, after we have these areas on the tail, we need to find the values of this area using calculator. So in our calculator, we go to second, then vars, and number 2. So here we are going from negative infinity up to negative 0.5212. So let's do that. So the lower limit is negative E99 or negative infinity. Upper limit is negative 0.5212. So we are using the standard normal distribution because we are using the z-score. Paste all this information, hit enter. So we got area on the tail, on each tail in fact, 0.3011. So this area is 0.3011 and this one is also 0.3011. Now you can calculate your p-value. So the p-value is the sum of those two areas, 0.3011 plus 0.3011. So if we add these two areas, that is equal to 0.6022. So this value is our p-value. Now what we are going to do is we are going to compare this p-value with the significance label here. So what we see is our p-value, which is 0.6022, is in fact greater than alpha, which was 0.05. So we got p more than alpha. Meaning of that is we failed to reject null hypothesis. If this condition is true, we failed to reject null hypothesis. Let me write that. We failed to reject null hypothesis. Null hypothesis. Okay, so we failed to reject the null hypothesis. We fail to reject means we are not rejecting this. We are not rejecting the null. Instead, we are rejecting the alternative hypothesis. We are rejecting the claim. Meaning of that is there is not enough evidence to support the claim because you're rejecting the claim. So there is not enough evidence to support the claim at 5% significance label. Okay, there is not enough evidence to support the claim at 5% significance label. So that is the end of this example. We are testing whether the claim that there is no difference in the age group of two group of students, that is the resident student and commuter student, is true or not. But we saw that that is a false claim. So there is not enough evidence to support the claim. That is the end of this video. I hope you find this helpful. Thank you so much for watching.